Hello everyone, welcome to In 5 Minutes. In this video we are going to solve discrete Fourier transform using the transformation matrix. Let us see the question. Find out the 8-point DFT of the sequence x of n 1, 2, 1, 2. But we can see that the length of the sequence is only 4. We have to make it 8. So to make the length of the sequence 8, it can be done by zero padding. It is basically a method to add extra zeros to make the length of the sequence 8. So finally we get a 8-point sequence after adding 4 zeros. Now we have to frame the twiddle factor. Wn is equal to e raised to minus j 2 pi by capital N. Here n is equal to 8. So it turns out to be e raised to minus j 2 pi by 8, which is e raised to minus j pi by 4. Now W8 raised to kn turns out to be e raised to minus j pi by 4 into kn. Here the range of k is equal to 0 to n minus 1, which is 0 to 7. So now we are going to find the W8 raised to kn matrix. So W8 is equal to, we have to find accordingly to the values of n and k. So n varies from 0 to 7 and similarly k varies from 0 to 7. So when we write W8 raised to 0, that is k value is 0 and n value is 0. Similarly for all the first row it turns out to be same, and same happens for the first column. Now looking at the values of k and n, in this position we get W8 raised to 1. Here the value of k is equal to 2 and value of n is equal to 1. So k into n turns out to be W8 raised to 2. Similarly in this position W8 raised to 3, and it goes on same way. Now in this position the n value is 2 and the k value is 1. So it turns out to be W8 raised to 2. Again k is equal to 2 and n is equal to 2. So W8 raised to 4. 3 into 2 6. 4 into 2 8. 5 into 2 10. 6 into 2 12 and 7 into 2 14. We can see that there is a different way or a simple method to find out directly the terms rather than multiplying. If n is equal to 1, we can add 1 to each term. For 2, we can add 2 to each term, and similarly for 3, we can add 3 to each term. And we can follow this method up till 7 and form the matrix. So this will be easier while solving in an exam. So it rather avoids the confusion in the terms. So finally, after performing these same steps, we get this matrix. But we know that the twiddle factor has cyclic property, so we don't need to find the values of each and every term. We know that W8 raised to 0 is similar to W8 raised to 8. Again, W8 raised to 16. So the multiples of 8, that is finally equal to 1. Similarly, for W8 raised to 1 is equivalent to W8 raised to 9 equal to W8 raised to 17 equal to W8 raised to 25, and it goes on, which is 0.707 minus j 0.707. So we can see that there is only need to find up till W8 raised to 7, and the rest of the values can be easily found out by just incrementing this value by 8, because it turns out finally to be the same value. So let us see what are the values and what is the final matrix we get. So after finding the values of each and every term, we get such a big matrix. But it is very easier to solve because the last 4 turns out to be 0. So finally, after multiplying these both matrices, we get the answer as 6, 1 minus j 2.414, 0, 1 minus j 1.828, minus 2, 1 plus j 1.828, 0, 1 plus j 3.828. This is the final DFT.